One of my favorite memories as a kid was going out to eastern Oregon in the John Day fossil beds with my family and spending time hunting for fossils. There's just something so exciting about that process of discovery. Digging in the ground to pull up some rock, to crack it open, and just maybe in that rock you find something that no one else had ever seen before. Some organism that lived millions of years ago that's now in your hands. It's an amazing feeling. It's a feeling I hope everyone gets a chance to experience. But that experience begs the question, makes us ask the question, what is a fossil? Well, in this video we're going to explore that. We're going to answer the question, what is a fossil? So in this video we're really going to be doing two different things. The first thing is we'll answer that question. We're going to define the term fossil, and we're going to look at some of the key characteristics that make something a fossil. And two, then we're going to describe the process that made something that was alive become a rock. So we're going to do those two different things throughout this video. So let's just jump in. What is a fossil? Well, for my class, we're going to define a fossil as any naturally preserved evidence of life. So it's got to, if we look at that, that means it's been preserved, it's here still today because some natural process. So that changes some of the things that maybe you see on some other YouTube videos and some other channels that say what a fossil is. It's got to be a natural process, and I'll let you find that out on your own. I do want to put some restrictions on that. Not because we don't want to be interested, but because we want to separate subjects. Some things are science and paleontology, and some are archaeology. So because of that, we have said that a fossil, and we meaning scientific community, has said a fossil is some evidence of a life, something preserved evidence of life, that occurs before humans. Right? It's older than humans have been around, or you could use the term prehistoric. Right? So prehistoric means it's before humans, before human history. Well, human history stretches back about 10,000 years if you go back to Egypt and Mesopotamia and some of the other cultures. So really, we could say a fossil is some naturally preserved evidence of life that is older than 10,000 years. You could watch some of the other videos and figure out and find out how we know the ages of different rocks and different fossils. So looking at that, that means a couple things. First off, a mummy is not a fossil. Yeah, they're old and they look like they're a fossil. They're all withered up and shrunken and kind of salty looking. But they're not a fossil because they're not in that time range, right? They're Egyptian, so they're in human history. And they're also not naturally preserved. Someone actually did something to them and to make them a fossil, a case of mummification. So mummies are not fossils. But lots of things can be fossils. In fact, any evidence of life. So that could mean a bone, right? We think of fossils, we think of dinosaur bones usually. I know when I was out hunting for them, that's what I thought of. So bones could be fossils. You could have skin, teeth, plants, fossilized eggs, shells of an egg, or even just a shell of an animal, footprints, even their poop, their dung. It's called coprolite, can all be evidence of life and can be fossils. In fact, when we find fossils that aren't directly the animal, so it's not the bone, the skin, the teeth, or a plant, or even an egg or shell, we call those, so it's like footprints, we call those trace fossils. And even those fossils can tell us a lot about an animal. They can tell us how the animal behaved and acted, and compared to maybe a bone, which would just show us what they looked like. So a fossil could be any form of evidence, and like I said, there's a ton of different types of them. All of these fossils, though, go through a natural process to occur. In fact, there's 9 steps that we're going to go through that will show something going from something alive, swimming around, to a rock that you dig up. And so the first step to forming that fossil is that you have to have something alive. You have to have some living form. And so for the sake of the argument today, and for this video, we're going to have Carl the fish. And so we're going to see the process that Carl the fish goes through to come from alive to a rock. And so step number 1 is you have to have life. So Carl swims around the ocean. He has a great life, eating and doing what fish do. But ultimately, everything that's alive dies. And so the second step for forming our fossil is something has to perish. So Carl, he lived a great life, but eventually his time has come and Carl died. He slowly sunk to the bottom. And yes, I realize sometimes fish rise up, but eventually the gases leak out and they fall and settle to the bottom. If not, we'd have the top of the ocean covered in dead fish. They eventually sink back out. And when they reach the bottom, they sit on the floor. Now, things that are on the floor always undergo scavengers and rotting, and things fall away, and the same thing happens to Carl. Other fish might come and peck at him and pull off bits of Carl and take away, and the circle of life continues. But for our third step, some form of Carl has to stay there. So scavengers don't eat the whole thing, they leave some remains of Carl. So it might be bone, it might be some skin, it might be a tooth, it might be all the things that we could look at as a fossil. So some remains of Carl are sitting at the bottom of the ocean. Well, eventually, all fossils are covered up with some material, and it's usually mud. And so, just for our case, Carl's sitting at the bottom of an ocean when a landslide comes and it covers Carl in mud. That covering in mud really is going to help protect Carl, because now scavengers can't get in there to pull pieces of him off. He can stay there for a very long time. So as the mud covers up Carl, it starts to build up. And maybe there's life that goes on above it, but over time, more and more sediment, more and more stuff are building up on top of it. He's kind of getting squished. All that heavy mud and sand and silt and everything else in the bottom of the ocean or a lake starts to push on him. And the sand and silt and all that material slowly turns from mud and sand, starting to turn to rock. But Carl's in there, and bone doesn't like to turn to rock. So as the area, as that rock is starting to form, something occurs called substitution. In substitution, it's just like you have substitution in math, where you take something away. In substitution for a fossil, the calcium, the pieces of a bone, are being taken away and other things are coming in. Things like silicon or iron or all sorts of different atoms and minerals are taking the place of the bone. So when we finally at the end get to dig up Carl, there really isn't any bone left. There's just the remains, the evidence of a bone. So Carl, he is now just little bits of silicon that look like a bone, and he's covered up. Over millions of years and lots of time, this rock is being bent by plate tectonics. It's being shifted around, and it might rise up to the surface eventually. It's being squished and changed and deformed by all the pressure and heat that comes on our planet. Eventually, though, plate tectonics will push that rock up to the surface. When it does get to the surface, the rock that now has the remains of Carl that have been fossilized and turned into silicon that looks like Carl, those remains, gets to the surface, it begins to weather away. Ice and snow and rain and wind are starting to wear that rock away, to what has remained to the outside is just the remains of Carl. Just those, the fossilized bone that are left. When it's on the surface, now all of a sudden we can see it. And paleontologists will come and dig it out, or myself, one of my expeditions, will go and find it and dig it out. And now we have the fossilized remains of Carl. So that is that process. Now, obviously it will change, that's just an example, but the idea that things being covered, dead material or footprints being covered up and slowly being changed to a rock is really that process we're going to see over and over again for a fossil, and it takes that 9 steps that we just talked about. So what did we do in this video? Well, we did a couple things. One, we defined what a fossil is. We said it's any evidence of life that is naturally preserved. We said that it has to be older than human history, older than 10,000 years. We looked at that process that forms fossils, and I said it's about 9 steps, but the highlights are that material is covered up with sediment, making a sedimentary rock, and The rock is substituting out the calcium to create a fossilized bone right there, or a bone or any other remains, which plate tectonics moves up to the surface where weathering erosion reveals it to make a fossil, and we find it on the surface. So let me remind you how these videos work. You can always stop and hit pause if I'm going too fast, or go back and watch a whole section again, or maybe just take a break and watch it later. But always remember to keep moving forward.